So in the last session, we have seen agent with no memory, also agent with memory, where we will ask a question and that context has been given to the LLM, and from that context LLM has given the answer to us by identifying a tool, right? So exactly what happened, we asked a question. Based on the context in that question, LLM identified it needs some additional information and it requested us to make a tool call. And the agent, as part of the application, it made the tool call and the same answer has been given back to the LLM, and LLM has synthesized the context, again that answer presented us in a presentable manner, correct? Now, today I'm going to show you RAG, Retrieval Augmented Generation. Okay, remember these three keywords. If you remember the LLM, what exactly it does? So it has been built or it has been trained on a huge corpus of text, right? That corpus of text, of course, it has been trained somewhere around like 2023 or 2025. There is always an end date, right? Isn't it? Now, after that date, whatever it is happened in the world, basically that LLM might not be knowing that. Okay, that is one limitation of that LLMs, right? Correct. Um, Apart from that, if you look at the enterprise systems, I will show you one example here. Look at this. Let's say this is the Acme Corp employee handbook, right? And if you look at this handbook, there are several paragraphs and all. Say, for example, a paragraph that contains about the work hours. Acme Corp standard work hours are Monday through Friday, 9 a.m. to 6 p.m. local time. Employees may request flexible start times between 8 a.m. and 10 a.m. with manager application approval, right? Core collaboration hours are 11 a.m. to 3 p.m. Correct? Similarly, there is a one more, that is remote work policy. There is one more, paid time of parental leave. This is one document, okay, which is purely owned by the Acme corporation company, which is not available in the public domain. So that means LLM also does not know about this one. LLM has not been trained by this because these documents are owned by the companies and they were internal to the company. Okay, they are not exposed to the public. This is just an example. Okay, now you see the another document. Earlier we have seen the company handout document for employees. This time it is Acme Cloud Product, facts. So it's the fact document, pricing plans, what is Acme Cloud, how do I deploy an agent, rate limits, etc. And the written policy, there is one more document on the written policy and all. So this is also text, right? Now the companies wants LLM to make use of this information and to retrieve the proper answers back. Correct? Now, how we can do that? The one way is that the whole content, the whole information, let us say, we know that LLMs are excellent at language, right? And weak at our company's private and current facts because LLMs don't know the private current facts. And whatever we have seen just now, let's say the latest PTO policy or product pricing table or the written policy, isn't it? They were not there as part of the LLM, correct? Before RAG, probably I will touch base this also. Before RAG, what industry has tried and whether they succeeded or failed. Say, for example, in the first attempt, they start a chatbot, a simple chatbot saying, how many remote days does Acme allow? And ironically or interestingly, LLM will give some answer. It will not say, I don't know. Actually, LLM does not know about these documents, but still it will give some answer. The reason is LLMs are prone to hallucination. That is one problem. Okay. So what is the industry pain points here? If you look at the legal or compliance, right? I mean, they cannot accept the unauditable answers. The hallucinated answers and all, the legal and the compliance will not at all accept. So that is failed. Now let's look into the another attempt B or attempt 2. The whole corpus of these private documents that are in the company's private domain, probably we can fine tune the model on these documents and create a new model for our own sake, right? But again, when the document changes, again we need to uh, train the model, no? So that's also expensive because of the GPU time, because the current LLMs and all, they have like billions of features, right? Isn't it? And the corpus is heavy, and GPUs required to train them are heavy. Okay, and every time when we train them, and MLOps, will have to take care of the whole MLOps pipeline, isn't it? And even if we do the training, yesterday's fine tune, whatever fine tuned, we still the answers the last yesterday's only. Whatever we have changed today, it will not answer. So that is another problem, because from the industry perspective, policies change very weekly, let us say, and the fine tuning cannot keep up that pace. Whatever the answers those LLMs give, auditors want evidence, not just vibes. Okay, that's also failed. Now the third attempt, stuff the whole knowledge of these documents into a prompt. This is also problem. The reason is, when we are calling LLM APIs, the context always has the limit and all. And even if you start putting the whole information every time we hit the API, the cost will be enormous, and we will be paying a lot of things. And one more thing, the latency will be huge, because it has to find out the needle in a huge haystack, no? And not only that, even the attention dilution will happen to the model, because the model misses that needle. What we need is a small needle, but what we have given is the LLM to the haystack. A big information we have given to the LLM, which 99% is not required for the particular context. And for that 0.1%, LLM has to go through all that additional 99.99% also, which is waste of time, money, okay, and privacy leak risk, because we are unnecessarily sending the whole information, because these documents may have some privacy related information also. So this is also failed. So what is the another attempt that we can think of? Maybe we can search only keyword only. Let us say we do the control F and all, enter some word, okay, and we can do the keyword search, right? Let's say user gives that, can I work from home some days? What the document will say? It will, keyword search means it will try to exactly find those keys, okay? Full-time employees may work remotely up to 3 days or something like that, okay? But the context is different, right? Isn't it? The context, wordings are different, the meaning is same. Sorry, so the wordings are different. The user has asked about the work from home. The doc says full-time employees may work remotely up to 3 days. They both are related actually. So it is something that we should be able to get that particular information by semantic meaning. Isn't it? A canine can be a dog, or maybe with whatever, like the tooth and all, like dog, or whatever, fox, or all these canines only, right? So that semantic meaning, the information we should be able to fetch. Now here also one pain point is that user is basically asking in the natural language, but whereas the policies are written in legal or HR language kind of things, right? So this is where the RAG came into picture. What exactly is RAG? Retrieval Augmented Generation. What exactly it does? Number one, retrieve. It only the few passages that are relevant to this question are retrieved, not the whole document. Number two, augment. LLM prompt this augmentation, right? The LLM prompt with those passages, whatever we retrieved, has been given to the LLM. That means only the required passages or required chunks are given to the LLM. That is the augmentation. When the LLM see only those required augmented information, now LLM is able to give a proper answer. That is the generate an answer that must stick to the evidence. So without the RAG, LLM answers from memory or guesses. Whereas with RAG, LLM answers from the pages we just looked up. At the auditing, we can easily say that it has been retrieved. The context or the chunks that we have given to the LLM to provide the answer has been retrieved by some document or some vector store. I mean, I will explain to you what is vector store, okay, or some database or something like that, right? Isn't it? So there is an evidence, auditor will be happy, and also there is no hallucination, isn't it? So this is exactly what the RAG solves, okay. And what else? Probably we can go ahead into this one, right? So these are all the documents. Company handout.txt, product facts.txt, written policy.txt. This is the knowledge, company knowledge, right? It can be any knowledge. These are the, just for the demonstration sake, I have shown 3 txt files. It can be PDF file. It can be a lot of document repository the company maintains, isn't it? So what we discussed about RAG is retrieval augmented generation, right? How that happens? The retrieval augmented generation, the first step is the whole document is chunked into multiple pieces. Okay, look at this document, right? This whole document, suppose the first paragraph is talking about standard hours. Can I chunk it? Can I take this as a one piece and store it? Okay, and this one about the refund timeline, right? Can I chunk this and store it separately? Can I chunk this and store it separately? Can I chunk this and store it separately? That means there should be an algorithm or a small function where, given this particular document, you should be able to split this whole document into multiple chunks. Here, like one chunk, another chunk, right? If you look at chunking styles and all, it could be, I mean, if I want to explain to you, probably one is generally, paragraph based chunking. I mean, when we are going through some, like books and some kind of like stories and all, generally paragraphs, they follow the context, right? So it's easy and intuitive also, okay, because that particular paragraph is limited to that particular context and all. Of course, there is a relation between the past paragraphs also. Okay, so this is one of the best approach. Another approach is probably fixed length chunking, right? Let's say stick to like 500 chars or 400 chars, something like that. But at the same time, while fixing that length, make sure that we are not cutting the text. Like, let us say 400. How many characters of this one? Let us say how many? Okay, 222 selected. Let's say 222, 220 we are going. You should not able to cut in between, right? I mean, at least we'll have to wait until the full stop is there, where there is a space is there, or at least a new line is there, correct? So that's how we do, and start doing the chunking and all. Sometimes what happens is that for continuity of the context and all, probably we will take, when we are chunking this one, we'll take this like 300 chars or 400 chars, whatever. No, I mean, we will be putting that limit, right? Here it is a 223. Imagine that we put 220 or something like that. But additionally, we will take, like 10% of it. Let's say the previous 100 chars or something, right? Because of the continuity of the context, like this will happen. Probably like this will happen. So that continuity of the context will be there. This is the chunking, right? Now, after doing the chunking, we have to store it, this one, no? How can we store this and how do we retrieve it? So that's where these vectors come into picture, right? I mean, if you understand vectors and all, what is cos A dot B? If you no, I mean, if you come, I mean, you have come across this mathematics, right? A dot B is what is this? I mean, when the two cosines, right? I mean, there are two parallel lines are there, cos A, cos B, right? Cos A dot B, let's say AB cos theta, correct? There are two vectors are there. Let's say this is one vector and this is another vector is there. This length is 20, this length is 10. Let's say two are parallel. What is called dot product of these two vectors? Length of this vector and length of this vector multiplication, okay, a multiplied by b and cos theta, right, in between, ab cos theta, right, the parallelity. This cos theta 0, cos 0 equal to 1. So that means these two vectors are cos theta equal to 0 means completely parallel, we can say. The magnitude and all basically comes with multiplying the sizes of these vectors. If you take the unit vectors and the length of this vector will become 1, the length of this vector will become 1, and only the angle will define whether they were parallel or completely perpendicular. If they are perpendicular, what will happen? Theta equal to 90 degrees, cos 90 equal to 0. That means 0 means what? They were completely irrelevant. 1 means what? It's completely parallel. That means the context that whatever we are speaking, right, intuitively it will give the information that when the multiple, okay, this is how it happens, right? These chunks and all, right, these chunks we will convert into vectors. Let's say semantic vectors. When I say semantic, it's not going to purely store dog as dog, okay? It will identify dog as a canine or something like that. There are semantic meanings are there. So when you give the dog, it identify that, okay? Similarly, when we have given a text and all, that text will be converted into a vector. Let's say multiple dimensions, maybe GPT Mini 3 model, if you look at it, around 1500, that is something like that, the dimensions will be there. In those dimensions, it will build a vector for that particular sentence or the chunk. Now, when we give a question to the user, what will happen? That question also is converted into a vector, okay? And this particular question vector will start comparing with the vectors in the store, and whatever the vectors, they were bit of parallel or similar, right? Similar in the sense what? Bit of parallel. If those vectors are completely parallel to these vectors, that means they were all very resembling the similar nature, and they were the checks that we need, okay? So suppose if those vectors multiplication gives 90 degrees almost, value 0, that means they are irrelevant kind of thing, okay? That's how we fetch the information, okay? So I will show you here the chunking and all. So this is language, this is knowledge, right? Now if you look at the data, vector index.json, right? This is how it is. Embeddings are done, right? Embeddings. Look at this one. This is chunk. The text of the chunk is this one, okay? We have given the chunk ID. We have given the source also. Source is the document information, like company underscore handbook.txt, and the chunk ID we have given. Okay, I mean, like we just given some format here, like part 0, part 1, something like that. And we also started giving this start char and end char, something like that. This is the indexes. It starts with the 0 in that particular document. The end char of this chunk is 319 character, right? Okay. And embedding it, this is exactly the vector that I am talking about. So this particular chunk has been vectorized. You see, there are so many dimensions, right? Almost like more than 1500 dimensions vector, this one, okay? Like that, all the chunks are there. You can see many were chunked. All the 3 documents were combined into one single document. That particular single document has been chunked, and every chunk has been vectorized and stored here, okay? Let me show you. Maybe I will search with chunk. Yeah, you see this one, this is another chunk. So many chunks, right? You see? Return policy.txt. So all the chunks are there, all the documents, all those 3 documents were chunked and kept it here, converted into chunk ID, this one, okay? Converted into vectors. Now, if you look at embeddings, right, or chunking, you see, this is exactly what I explained to you, either fixed size chunks with some overlap or paragraph wise, okay? If you look at this one, there's a chunk class we have written here, and what we are going to store in the chunk, I just showed you, right? The text of that chunk, source, that is the file name from where the chunk has been taken, and we have given the chunk ID, okay? And the start character and end characters, indexes of that chunk in that particular file, okay? And these are 2 ways, right? One is fixed size chunk. I mean, giving that information like chunk it with a fixed size, right? Text has been given source, chunk size 400, overlap 80, right? So this is how it will split the information. Okay. So min and chunk size it has taken. At the same time, it will look for the, a proper ending and all here, so that it won't break the words in between. Okay. And those pieces it has taken and appending into the chunk pieces. Correct, isn't it? Similarly, this paragraphs and all, it is easy to identify. Like when there is a new line and all, generally it is treated as a paragraphs and all those chunks were taken. Okay, again it has been appended to the this chunks list, isn't it? And once these chunkings are done, embedding have to be done. That is vectorization, right? Each chunking has to be vectorized, right? Look at this embeddings.py. Okay, embedder. So what we are doing here is that default embedding model that we are going to use, text embedding 3 small. Okay, this is the OpenAI embedding model which has been provided to us. Okay, so it has taken the client as the OpenAI, and the model is this one, OpenAI embedding. This is the text embedding model. The documents that we have are the text only, right? That is the reason we are using this text embedding model. Okay, and then embed one or embed many. Generally, embed many is cheaper because it's going to embed the whole batch of chunks. Okay, if you look at this one, embed many, you can see that there's a list of strings are there. Each string you can consider that as a kind of chunk and all. So we are making a call. The client is the OpenAI, and we are making a call like embeddings that create the model we are passing, and then input as a text and all, and we got the output, ordered output of it, right? Okay, and then we return it. Okay, now look at this one, no? Main.rag.py. What exactly is doing this one? So there is a OpenAI client is there. Okay, and we are storing the build index and all. So what exactly this build index will do? You see this one, main.rag.py. It's using the build index, right? Yeah, agent with rag, no? So basically it's importing the agent with rag. Okay, so we're passing the client here. Okay, we are whether to force the rebuilding or not forcing. If we don't force, basically we look for the existing file, or if you're forcing, it will recreate it. Okay, if index path exists, index path here we have given is the model is GPT-4.1 mini. System prod we have given here. Top K is, I mean, the similar chunks, basically the top 3 similar chunks has to be returned. That's what it means. A system prompt we are giving to the LLM. What we are trying to tell it is that you are a helpful company assistant. Answer only using the provided context except from company documents. If the context does not contain enough information, say you do not know based on the available documents. Do not invent policies or prices. Okay, so this is something very serious and very useful. We definitely has to give this to the LLM so that it should not hallucinate, it should not create or invent any information on its own self. Okay, so here what we are doing, we are basically taking this one, we are loading the documents here. Okay, from this knowledge, all this we are loading, and we are embedding it. We are calling this embedder, right? You see this one in the embedder model and client, it has taken embed one, embed many. We have seen, no? This is exactly we are calling, right? Okay, and then what it is doing, you see, source text in load documents and all, it is loading all, and then it is creating the chunks, all chunks. Okay, it is sending to the embedded many all the chunks at once, and it is getting the embeddings. Okay, and after that we are storing it all the chunks and saving it into the path. Okay, vector underscore index.json. If you see this one, we are storing it under data vector dot underscore index.json. This is exactly what I shown you and explained to you earlier also. Okay, suppose I will delete this. Okay, I will delete this. I will show you. I will run this Python 3. You see this one? Building the vector index from knowledge. So it has recreated the vector index. I will show you. This has been recreated file. This has built it. Okay. So from the company handbook, it created 4 chunks. From the product facts, it has created 3 chunks. From written policy document, it has created 3 chunks. And it has indexed all the chunks, 10 chunks into this particular vector underscore index.json. Okay. Now, what I am going to do is that I am going to ask a question to it. Okay. What exactly we can ask? Okay. Tell me the written policy of Acme company. I don't know what it is. Let me see. Okay, what exactly it mentioned? Yeah, agent. It's the response from the agent. The return policy of the Acme store is as follows. Customers may return unused products within 30 days of delivery for a full refund. Items must be original packaging with all accessories included. Opened software licenses and digital downloads are not eligible for return. So it has given all these things very nicely, fantastic. For exchanges also it has given. For damaged items also it has given. And it is showing us the source. This is exactly the auditors want it, no? The above information is fine. But what auditors want is from where this particular information has been given. Now, this source as written underscore policy.txt is what auditors will go and check, and they are happy that LLM is not hallucinating and is doing perfect. Okay. This is one how RAG is useful for the enterprise companies. Okay. Or I will probably we can ask one more thing. No. So what else we can ask? Explain the work from home availability to the employees. You see, what I asked is explain the work from home availability to the employees. So, and it says full-time employees at Acme Corp may work remotely up to 3 days per week. However, they must spend at least 2 days per week in the office. So it is able to understand, no? You see this one, contextually when we ask for the work from home availability, it is able to match to this remote working of up to 3 days per week, isn't it? This is exactly semantic search and all. So this particular question has been converted into a vector and it started searching into the chunks. This particular chunk is similar to this thing. So this vector semantically it talks about remote working, work from home. It is matched there. Okay. And this also is matched to the same thing, like remote working, work from home. All these things are converted into that particular vector only. That's how it's able to identify. Okay. So this is RAG, Retrieval Augmented Generation. Now, okay, we have seen the chunking, that whatever the pages are there, right? I mean, we are able to chunk this remote work PTO, the leaves and all these things and all, and we are able to do the embedding also. Okay, and vector database. Okay, I have shown you the vector index, whatever the embedded things I'm able to show you, and vector store also. If you look at it, vector store, that is the searching, right? The searching also I have to show you, how the searching is happening. Vector show store. Where is this? Yeah, vector store, right? If you look at this vector store, okay, this is exactly where the search is happening, no? So class is the source stored and cosine similarity. This is the search is happening here. Okay. So this is a vector, list of all the float. This is also another vector. Basically, we are sending to this function 2 vectors. One, this vector represents the quotient. This vector represents one chunk. So probably in this is not an efficient program because here we are basically searching for all the, that particular question we are searching with respect to all the, for each, with each embedded vector and like 12 vectors or whatever it is, which is not efficient. Okay, so that is the reason, we will have to go for the ideal databases like Pinecone, etc., kind of things and all. Probably that I will cover later and all. Okay, these were simple cosine similarity. Okay, one means what I mentioned you, right? If both vectors are parallel, that means they were same, perfectly same, 100% same. If that is the case, the angle between them is 0. When angle between them is 0, cos theta, cos 0 equal to 1. That means they were completely identical. Suppose if the meanings are them are completely orthogonal, that means they were not at all similar. There is no similarity at all. Let us say my question is about, let me show you. Okay, let me show you. Um, how is the, what we can ask something, vegetables cost here, there. I don't know, some junk I asked. You see, I do not know. We have given the prompt, no? Only get the information based on the text given to you. Okay. So the vector store, it came to this cosine similarity. It has embedded this. How is the vegetable cost there? And it has gone through each and every embedded thing and all. It has identified orthogonal. That means they were all completely unrelated. These vegetable things is completely unrelated with respect to these company documents. That is the reason it returned 0. When the 0 and all, the LLM identified based on the prompt, it does not hallucinate. It says that I don't know. I did not get any information. No available information in the documents. Okay, this is exactly what is happening here. We are taking the dot product here. Like, what is the dot product? Cos A dot B, right? AB cos theta. Okay, and then yeah, some normalization is taking. Basically, it's a unit vector purpose, and then this is also normalization, and then yeah, dot divided by this is an, yeah, unit vectors and all, right? Basically, we will get, the values here. 0.1, 0 to 1 values will get here. Okay, the values nearer to 0 means they are mostly comparable. Okay, this is the vector store. This will be called main rag. What is this? Main rag, right? Main underscore rag. Build rag agent. Okay, yeah. So in the main underscore rag, yeah, build index. This is where the index has been built. Okay, and yeah, use memory true. That means all those chunkings and all, embedded vectors we have put it in the memory. Okay, we are not using any additional database here. So while true, it will be asking the question to us, and then we start typing it. Okay, run agent with memory client store. Okay, so the answer and all you will get it from here. You see this one, embedder, it has used OpenAI embedder and it hits, it retrieve. If you go to retrieve here, okay, agent with rag, this retrieval, store dot search, right? You see this one, this is the search. What is this? This vector store only, no? This is, so the search is coming here, right? When we put a question and all, for the searching and all, this function is being called. So query embedding, this is the question, and basically we are telling that, retrieve the top 3 documents which are similar to this particular question and answer, right? Okay, return the top k chunks. Okay, scored is cosine similarity, item embedding. Okay, and then we are checking it and we are sorting it. So anyway, for this particular question, they were completely orthogonal, so it won't retrieve anything. Okay, so this is the vector underscore store, which is a simple cosine this thing and all, which is not efficient in the production systems and all. Let us say you have like 1,000 or lakhs of embeddings are there, and we cannot compare for each question, to against every embedding and all, isn't it? So there has to be a efficient way. That efficient way we will see later. ANN or some different ways are there and all. Okay, so this is the RAG, Retrieval Augmented Generation. Okay, And one more, well, retrieval is there. Yeah, the generation, the needs to have show the evidence, right? I mean, that's what I have shown, the evidence, it has shown the policy document name also, correct? Okay. Um, yeah, if you compare without rag versus with rag, what will happen? The private facts, whatever the facts that are part of the, enterprise private repositories, if we don't have the rag, there is always a possibility LLM will do the hallucinations. So our audit will fail. It is a serious problem. With rag, what will happen? The private facts will be retrieved with an evidence. The evidence will show this is the document. Example I have shown you. Okay. And without rag, the what is the another thing the private will have to do is that probably they will have to do the retraining on top of the policy updates every time. We just discussed it, right? I mean, which is a pain point and all. Okay. So with rag, what we can do whenever the new policy update comes and all, we can re-index them. When we do the re-index and all, that's all. Nothing else needs to be done. The whole thing will work. Okay. And without rag, there will not be any citations and all. LLMs can't tell you that this is the source I'm picking and all. Whereas with rag and all, we can definitely get the source linked answers. Okay. Yeah. So without rag, again, like from prompt to stuffing, right? I mean, there's a latency. If we stop the whole information to the LLM, again, there's a latency wall. There's a cost associated, right? Whereas with LLM, we are telling that retrieve only the top three similar chunks, like the top three, top four, top five, context similarity, correct? So this is which is a cost effective, which is a scalable pattern. Okay. So RAG is required in industry because businesses cannot ship answers they cannot ground, they cannot update, they cannot audit. These things are very, very important. So since the plain LLMs cannot do all these things, we need the RAG on the private documents. Okay. Okay. So I will also show you one more thing. This is RAG, right? This is the same thing, another module, which is the rag main underscore rag underscore langchain. Why I am talking about langchain here? The reason is that if you see our whole implementation of our rag and all, basically what we are doing chunking. I mean, first of all, we are loading the documents, loading, and then chunking. Each chunk we are embedding into vectors, we are storing, we are retrieving, isn't it? And we are using some OpenAI models also, right? So LangChain is a framework which basically has, like interfaces above all these capabilities. For example, I will show you here. I hope you are able to see this screen. Okay. You see this one. Oh, anyway, I'm loading the environment here for the OpenAI key. And then we are importing build or load vector store, build ragchain. And then you see here, more or less same thing and all, retriever equal to build rag chain and all. What we can see here, we can, yeah, this is exactly right. If you see this one, LCEL, lang chain expression language chain, there is a question and there is a retriever, okay, and don't do anything to the question, just pass through, okay, and there is the retrieved documents or the chunks, it will be going through the format docs and all, and then it goes to the LLM as a prompt and we'll get the answer. Okay, you see this one, retrieval, right? This vector store dot as retriever search k, let's say top three documents you give, which are very nearer to our question, correct? After the retriever, okay, we are seeing that chart OpenAI model, answer model, this one, and then we are creating a chain here. So that chain, what we are doing, that from the retriever context, we are giving it as a piped format docs, right? Whatever the data we retrieved, these chunks, these top three chunks, and then we are sent through this format underscore doc. What exactly it is doing? It's clubbing, I think. Yeah, I think this just appending these blocks, okay, as a page content. And then we put the whole thing into a context, and the question, we are not doing anything, we are just saying that runnable pass through. That means don't touch the question and all, just pass it here. Okay, it's very similar to this whole chain. If we convert into a simple Python, it will be like this. Docs equal to retriever dot invoke question, first thing. Okay, this very simple, this one. Context equal to format, this whole thing, right? We are piping, no? After piping, we are sending that information to format docs, right? That translate to this line. And then messages, prompt format messages, we'll get the messages. And then after invoking this one, and then return a messages content. So I just simplified it for you to explain and all. Okay. And if you look at here, so I put some information here. First thing, load files from disk, then chunk the text, call an embedding model, store vectors, metadata, embed the question and search, stuff context into prompt, call the chat model, right? Okay. So LangChain provides reusable building blocks for all these things and all. So for example, document loaders, if you see, LangChain provides the document loaders for .txt, PDF, HTML, all these things. And it provides the, libraries for this splitting the text and all, right? I mean, recursive character, text splitter, etc. For embedded adapters also, it provides various adapters, Hugging Face embeddings, OpenAI embeddings. Vector stores also, it provides multiple vector stores, in-memory vector store, FAISS, Chroma, Pinecone and all these things. Retrievers also, like we have seen this, right? Search equal to K top 3 and all, right? So it provides this particular function as a, okay. And prompting also, right? Chart prompt template, chain, expression, right? Just now I explained to you, okay? Like retrieve, format, generate and all, correct? It's like a sequential chain. And runnable interfaces like do the things in a batching and all, or a stream, okay? Consistently, continuously. So it's not a new kind of RAG. LangChain is a kind of like a framework only. I mean, without RAG chain, we have done this one, right? Main.rag.py. What we have done? We ourselves created functions which can read the documents, which can chunk the documents, which can embed the documents, which can store the documents, which can retrieve, and all these things we have done, right? Whereas with the LangChain, it is a framework which will provide us to us. So we can use that framework. It is very simple for any startup, product generation and all. Okay, if you want to create a product, experiment it at a very speed and all, right? I mean, the LangChain is the best thing to do. Okay, this is good for the faster to prototyping, right? Okay. If you look at this one, see, we are importing the document from the LangChain core documents. Same thing. str output parser from output parsers. So LangChain provides all these things. It has provides the documents, output parsers, prompts, runnables, vector stores, and all these things. We just need to import them and start using them. Okay. So earlier we have not used this LangChain. I will show you. See, we have not used them, right? We have used our own things. Paragraph chain, embeddings, embedder, and whereas the LangChain provides these things to us. Framework it provides. We just need to fill. Okay. See, we have taken this rag directory LangChain index.json, okay, and the answer model we have given, prompt we have given from messages, okay, the same thing prompt we have given here, and the load the knowledge documents, okay. In the knowledge documents, this is the knowledge dir path is there, okay. Builder load vector store and all, correct. The same thing. Whatever we have done there, here we are doing the same thing. So paragraph chunk plus embedder many plus our in-memory vector store, LangChain is replacing with recursive character text splitter, OpenAI embedding, in-memory vector stores. These are specific to LangChain. Okay, here we have used our own things, whereas we are replacing them with LangChain specific modules. Correct? Otherwise, there is no difference. This is the LangChain thing. Correct? So LangChain is very simple thing and all. It's just a framework. Think of it. Once you have done this agent with RAG, experiment or whatever, example and all, then understanding LangChain is very simple. LangChain just a framework where the whole things we are able to do it using a LangChain framework. Okay. So yeah, this is about the RAG. We discussed about the RAG, right? What else we can probably? I think yeah, in the next session I will discuss probably in depth of the lang chain. Otherwise, we'll go one step ahead. Okay, thank you.